Morning, it's day 3 and here we are, sunrise over Eyjafjallajökull. I might have got the pronunciation wrong, I'm going to clarify that later today.
Before we get to today, we need to consider the final hours of day 2. We were treated to a great show from the Aurora Borealis, the Northern Lights. The solar winds create this phenomena, and I'd not seen it before. It's very emotional. Now off to Skoga Foss for day 3.
This is Skoga Foss, a 15 metre wide, 62 metre high waterfall. It flows over ancient coastal cliffs. The sea is just over there. These were formed by marine erosion at the end of the last ice age. Then the sea level was much higher than it is now. The weight of the ice age glacier pushed down the land. As the glacier melted and the weight was lifted, the land could rise and the sea level lowered. According to legend, there is a chest of gold behind Skoga Foss, where it would be hard to reach. For a long time, one end of the chest was apparently visible through the waterfall. Three men from Skoga once attempted to retrieve the chest, managing with great difficulty to place a hook in an iron ring on the side of the chest. They pulled hard, but the chest was so heavy that the iron ring came loose and the mission was aborted. The ring was placed on the door of the church in Skoga and can now be found in the Skoga Folk Museum. The following verse, bearing witness to this legend, has been passed down through the generations. The chest in Prazi's secret lair under the Skoga waterfall rewards the one who ventures there with endless riches, great and small. Right, just about to go up the Solheimajökull. Can't say it. Just about to get into my harness and my helmet. I have been given new boots. These ones. Slightly offended that the boots that I thought were quite geographical and would sort of do the job here apparently aren't crampon fit, so I've had to change. So I'm feeling a little bit hurt by that, but I'm sure the day will improve. I'm very excited to climb the glacier. Hello, I'm just on the Solheimajökull. This is ash from Katla from the 1918 eruption. I've got the mud from the ash of Eyjafjallajökull on my cheeks. Eruption 2010. And both of those types of ash you can find on Solheimajökull. Just been led down a big crevasse. It's a bit scary. Look back where I've just come from. Oh dear. Hope it doesn't close in.
This photo was taken by my good friend Chris Westwood in 2002. Keep an eye on the promontory of rock by the White Arrow and we should be able to compare.
Okay, so based on that photo evidence from Chris, it looks like the snout of the glacier was here in 2002. You can see the outline of these rocks here. I think it's probably from the photo I've just put on. And then actually, 2002 snout there, 2022 down there. And what is that? A couple of 100 meters? Maybe a touch more of retreat in that time. This is the village of Vic on the south coast of Iceland. It's halfway along the south coast, very isolated. It's about 50 kilometers to the nearest hospital, the nearest big shops and so on, the nearest big settlement. On the hill behind me is Vic Church. That was built in 1934, and that's where everyone in the village has to go in the event of a jökull up, in the event of a glacial outburst flood, which could be caused by the melting of the ice cap up in the mountains in the event of an eruption from Katla.
So behind me you can see some basalt columns that were once magma that have cooled, contracted and cracked at different speeds, which is why you can see that they are all at slightly different levels. This happens with igneous rock.
Right, the silica content of this basalt magma means that we usually get these 6-sided columns. Most of these are 6-sided columns. Sometimes they're between 3 and 9 sides, but these being lovely regular ones which have cooled down very, very slowly have formed these beautiful 6-sided columns. So these basalt columns, these are the interior of an old volcano which cooled down very slowly because they were insulated by the rest of the rocks around them. And then as we move out, we get to the more brown rock, and the brown rock was in contact with water and that was able to cool down more slowly, so it doesn't produce these lovely columns, these basalt columns, as we have in the vent just over here. What's it similar to in Northern Ireland? Do you know? Yep. Yeah, someone's just shouted it out to me. Giant's Causeway. As we arrived on this black sand beach, just next to and around the corner from Vic. There's loads of signs about how dangerous this beach is. There's a danger, the signs tell us, of being dragged out to sea. Irregular waves come and hit this beach because they've got huge fetch, and we get very different size of waves that mix in together and lull people into this false sense of security. So the rocks are all very similar along this piece of coastline. So why is there going to be differential erosion? Why are some of the rocks going to erode faster than others? And of course the answer lies in the joint pattern, the amount of cracks there are in each section of it, the individual rock, which might be caused by and affected by the speed at which the rocks have cooled down. So if it's got lots of cracks in it, then the forces of erosion are able to get into those cracks and are able to break up that rock more quickly. And this means that those places with a more dense joint pattern are going to erode faster. And it also means the places with a less dense joint pattern will erode more slowly, and they will become the promontories, the headlands, that ultimately will then become the stacks and the stumps and the arches. But then if you end up with headlands, then it means that the waves are going to refract and diffract, and they're going to end up attacking those promontories, those headlands, ultimately causing them to break down over time and erode away. Dorhirale, Dor Hill Island. That's the name of the arch. Icelandic arch example. Another one of Iceland's, and our final thing of today, another one of Iceland's famous waterfalls. I'm going to go with Skoga Foss. That's quite possibly wrong, I might update that. Very impressive.
Quick waterfall time lapse. Thanks for joining me. Bye bye.